Let me talk about some of the other extreme weather cases, including, for example, extreme wind and also wildfires. These are all part of the extreme weather in addition to ice storm. When you have powerful winds, what you really care about is what is the wind load on the conductor and how that drives tension load to the structures, the towers. And there's also the wind blowout, which actually defines the rights of way that you do not want to violate the rights of way. You don't want to infringe outside the rights of way. With TS conductor, we have a trap wire design, which is not only compact, but also you get a smooth surface. And when you have a compact design in conductor, you actually minimize the profile of the conductor under wing. So you will have less tension in the conductor, and that will drive less tension to the structures. What it means is it's going to allow you to manage these extreme weather cases better. The other part is the smoother surface compared to the round aluminum configuration. It is known to have a significantly lower wind drag. And actually in Belgium, if you have a smoother surface like trap wire or Z-shaped wires, you can take a 40% reduction in tension load. And I've also heard from other conductor manufacturers that they've done wind tunnel testing that they can benefit from a significantly lower wind drag with a smoother conductor surface. And these are not necessarily accepted worldwide, but the benefit is there. So if you do have extreme wind, the TS type of conductor with smoother surface and a more compact profile, which means the conductor is a little bit smaller, it will help you to deal with extreme weathers better, including resiliency and the improved resiliency under extreme weathers. And on the other extreme weather, which is wildfire, for example, I would also make the argument that when you have conductors like TS, they naturally have very low sag under heat. So imagine you have a transmission line that you got a wildfire that are passing through. That heat from the fire right below the power line will have minimal impact to the TS conductor for two reasons. One, the heat is not going to affect the sag of the TS conductor because we don't have really a sonar sag to worry about. The other part is the aluminum is already fully annealed. It's not going to get affected by the heat anyway. So the TS-based transmission line will have a much better chance of surviving the wildfire. And after the fire passes, the conductor will preserve its performance attributes. If you look at traditional conductor, for example, ACSR or ACSS, especially ACSR, when you have fire right below the transmission line, those conductors are going to sag dramatically and getting the wires a lot closer to the fire right below. And the temperature from the fire could be hot enough, melt the conductor. And if it survives, the aluminum would have been fundamentally changed from hard aluminum to annealed. So even if it survived, you have to go back, probably replace the conductor because it is not ACSR anymore. It is got annealed aluminum in there. You will have permanent saggings. That's going to create clearance violations. And so from wildfire perspective, TS conductor will also give our utilities better resiliency against those extreme situations.